Hello everyone, welcome to 11.6 part 1, which is all about geometric sequences, which comes perfectly after arithmetic. And our goal is to recognize what a geometric sequence is, and just like arithmetic, to find an equation for the nth term, again explicitly and recursively. And also just like arithmetic, the second video is going to be about finding sums. So the main difference between arithmetic and geometric is really the type of pattern between the output values. In arithmetic, we talked about common differences. For geometric, we talk about a common ratio or a common division. And a geometric sequence is defined as a sequence in which the ratio between consecutive terms is the same. And whenever I see ratio as written before, I think division, but remember that division is also multiplication. Like 1 divided by 2 does mean divided by 2, but it also could mean multiply by 1/2. So I want you to think about that geometric is really more of a multiplication or division relationship, and arithmetic is more addition and subtraction relationship. Now there was a little typo. This should have said common ratio, not common difference, because we're talking about geometric. And what the common ratio is symbolically is that your ratio would be the next term divided by the previous term, and that ratio would be the same as the even next term divided by the previous term. So these two ratios would have to be the same in order for it to be geometric. So again, let me show you what I mean by that. So just like arithmetic, we want to decide if this is truly geometric or not. So if we took a look at this first example, let's do some division. If I take the second term divided by the first, if I take the third term output value divided by the second term output value, this ends up being 4. This also ends up being 4. And if I take n equals 4 divided by n equals 3, that also ends up being 4. So my common ratio for the first example is 4. And yes, it's going to be a geometric sequence. Number 2, if I take the second term divided by the first, and the third term divided by the second, and the fourth term divided by the third, all the consecutives, it looks like each time I get an answer of -2. So that means that my common ratio is -2. And yes, again, we have a geometric sequence. So again, just notice I'm always taking the term afterwards and dividing it by the term right before. Number 3, if I take 1 divided by 5, and then if I take 0.2 divided by 1, and take 0.04 divided by 0.2, you can do this in your calculator, or if you want to change this to a regular fraction, see if it matches 1/5, remember 0.2 over 1, if you move this decimal over, is really 2 over, you have to move this decimal over, so that's really 2/10, which is 1/5, which is the same. And 0.04 over 0.2, if I move this decimal over twice, I get 4 on top. If I move this decimal over twice, I get 20 on bottom, which again is 1/5. So it looks like my common ratio is 1/5, and again, yes, it's geometric. Where life becomes more tricky is when we introduce more fractions. So if we take a look at number 4, if I take the second term, let me write that a little bit more neatly here. If I take the second term, 2/7, and I divide that by the first term. Remember, a fraction divided by a fraction is the same as the first fraction, 2/7, multiplied by the reciprocal of the second fraction. So that would be 10/7. So 10/7 is the common ratio between the first two. Now if I take 3/9 and I divide that by 2/7, and I change that to multiplying by the reciprocal, that would get me 21 over 18, and those are both divisible by 3, so that would be 7/6. Because 10/7 does not equal 7/6, there is no common ratio, and this one is not geometric. And I think that this idea of the reciprocal will really help you, not only on this example, but also the next one. I ask with these two what makes them geometric, so we're probably looking for a common ratio. If we look at this sequence, If we take the second term and divide it by the first term, that's really 1/10 times 5/2, which is really 5/20 or 1/4. If I take the third term of 1/40 and divide it by the second term of 1/10, that is the same as 1/40 times the reciprocal, which is 10/40, which is also 1/4. So I would say that this one, the reason it is geometric is because the common ratio is 1/4. In this example, if I take the second term divided by the first, the third term divided by the second, the fourth term divided by the third, looks like each time I get a ratio of 2, which means that my common ratio is 2 and it is geometric. So both of these, the common ratio determine that. And again, the question is, why does it matter and how does this relate to a graph? So if I take this example and I again write n equals 1, 2, 3, 4, whatever term I'm on, and underneath write 3, 6, 12, 24, just like the arithmetic video, I can graph these points and see what graph really comes out. So 1, 3, 2, 1, 2, 3, 4, 5, 6, 3, 12, 4, 24 would be probably all the way up here somewhere, easier said than done. Looks like this time my graph is not going to be completely linear, but to make sure, let me keep going with this pattern. If I have 1 and I wanted to go backwards to the 0th term, remember the common ratio is 2. So if I divided 3 divided by 2, that would get me this is 3/2, which is 1.5. And so if I graphed 0, 1.5, it looks like my graph is not linear this time. It looks like it's going to be more exponential. If I connect my points, it looks like I'm increasing more quickly, which also makes sense because when I have repeated multiplication or division, that really turns into an exponential equation. So that means that every time I graph a geometric sequence, it's really going to come out as an exponential graph. So just like arithmetic was always linear, geometric was going to be exponential, which means that my general equations are going to be in exponential form. Okay. Just like the arithmetic video, something else that I think would be important to point out at this time about this sequence is if I again, excuse me, trying to scroll down here, let me write down 3, 6, 12, 24. If I again wanted to find a recursive idea that a sub n plus 1 is something happening to the previous term, and if I looked from the first to the second, I'm multiplying by 2. Second to the third, I'm multiplying by 2. So my recursive sequence would be that the next term equals 2 times the previous term. And I wanted to point out also that notice that your R value is 2, and the value here I also got was 2. So if you're given a recursive sequence, that means that you're really given the R value for free, which transitions into the next slide. So if I wanted to find a recursive for any geometric, your next term would be your R value, your common ratio, times the previous term. So this is very useful, and again, this will come in handy later. I wish I had a cool proof to show the explicit. What I do know about the explicit, though, is that it's going to be exponential. So here is your general explicit formula for any geometric sequence. A sub n equals a sub 1. So far it's same as the arithmetic that we have the first term, but this time because it's exponential and we're using more multiplication, be a sub 1 times the common ratio to the n minus 1 power. Just for the sake of time, I'm not going to prove this. If you could just accept this for me. In class, your teacher may show you where this comes from. It's up to them. More importantly, let me show you how to use these two, and this is the one I'm going to be using more often. So let's get started on that. Let me write it again here. A sub n equals a sub 1 times r to the n minus 1. So if you were given that the first term of a sequence is 5 and the common ratio is 3/2, we want to find an equation so that we can find the 8th term quickly. And so this is a good one because I'm given the first term and the common ratio. I can go directly to the formula. A sub n equals the first term of 5. The common ratio is 3/2. We are raising that to the n minus 1. So if I wanted to find the 8th term, you would really plug in 8 for n. So a sub 8 would be 5 times 3/2 to the 7th power. And make sure that you're following the order of operations. In your calculator, please make sure to take 3/2 to the 7th first and then multiply that by 5. And if you do so, your final answer will be 85.43. The second example here starts off well. I notice that again we're given the first term, which is nice because we're going to need it for the equation. But unfortunately, like in arithmetic, we weren't given the slope. For geometric, we were not given the common ratio, which means I need to find it. So we're going to have to work backwards. But again, I do know this, so let's at least start there. A sub n equals a sub 1 times r to the n minus 1. I know that the first term is 5. I don't know the common ratio, but I actually do know what a sub n and n are because remember that this is really a point, 4, 1/25. And the 4 represents the term number I'm on, and the 1/25 represents the output value. So if we do a little backwards plug and chug, a sub n would be 1/25. We have the 5. We don't know the common ratio still, but we do know that the term number I'm on is 4. So we'd have 1/25 equals 5 times r to the 3rd. And if my goal is to solve for r, let me divide both sides by 5. And remember, dividing by 5 is the same as multiplying by 1/5. So you'd have r cubed equals 1 over 125. So in order to find what r is, my answer is a fraction. So I wonder, what fraction to the 3rd would give me this? Well, what number times itself 3 times gives me 1? Well, 1. What number times itself 3 times gives me 125? Well, that's 5. So that means that my r value is going to be 1/5. And how does that help me? Well, the goal of this problem is find a sub 9. So in order to do that, we need to find the general equation first. And we know that the first term is 5, and now we found that the common ratio is 1/5. So if I want to find the 9th term, all I have to do is plug in 9 minus 1. So a sub 9 would be 5 times 1/5 to the 8th. And in your calculator, if you do 1/5 to the 8th first times 5, your answer would be 0.0000128. So if we continue on to the next example, this one will be done by your teacher in class if there's time. So we're going to skip this one for now, and I'd like to go to the last example that looks like we're given the first term and a recursive sequence. Now, I want you to try as much of this on your own because, remember, we said that a recursive sequence, the r is multiplying your previous term. So if you look at this equation, you could probably tell what your r is. I want you to find the first 5 terms, see if you can find any of this information, and I will be back with my work. Give it the best shot you can because we've been practicing recursive for a little bit. All right, guys, so to check back in with you, I knew that the first term was 36. So to find the next term, I did negative 2/3 times the previous term 36 and got negative 24. Then I plugged negative 24 in, multiplied it by negative 2/3 and got positive 16. When I did it the next time, I got negative 32/3 and positive 64/9. If you had decimals for these, feel free to check your decimal versus my fraction. The common ratio I said was negative 2/3 because it was given to me in the lovely recursive equation. To find the nth equation, I already knew what my first term was here, found that my common ratio was here, so this is how I got my final equation, and then I used this equation to find the 12th term more quickly. So I plugged 12 in for n, and got negative 0.41619 as my final answer.